Welcome back to Math 105, Chapter 2.3, where we are talking about your financial calculator app in the ATI 84. But this time we are going to talk about what we do when we have any sort of payment. So to get started, make sure you have any sort of calculator that can contain your financial app. I just grabbed a free one online just to kind of work it through and show you what we're doing. So first things first, let's go to Apps, Finance, and TVM Solver. Now, we already previously kind of talked about these responses in a previous video, so please go back a few videos just to kind of reacquaint yourself with these values. Now, we're just going to walk through a few of these examples as seen in class and just kind of work through how to manipulate your app. So n is referring to the multiplication between m times t. I is just your interest rate as a percent. PV is your present value. PMT can be either in the form of deposits or withdrawals. And then future value is just going to be just that, FV. And then P/Y, C/Y is really just going to be how often you're compounding. So if we're starting with example 1, it says at the end of each month. Notice that I have highlighted at the end of each month. That is referring to this PMT option here. It's either happening at the very end or at the very beginning of your compounding period. So for us, at the end of each month, we want to make sure that PMT end is selected. It says you deposit $50,000 into an account earning 2% annual interest compounded monthly. Find the future value after 5 years. So they're telling us that we need to find future value given that we are depositing $50 for each month over the 5-year period. So n is the multiplication between your years, 5 years, and your 12 compounding period. So we can do 5 times 12. Your I is your interest rate, and we're just going to hit 2, and that's percent, so 2%. Your present value, right now, they don't tell us that we have anything in the account to start, so we can just leave it as PV. Your PMT is just how much are you depositing. So we know that we are depositing $50. We don't know your FV, we're trying to search for your FV. P/Y, C/Y is your 12, that is your compounding period. And again, it's occurring at the end. If it said the beginning, it would have stated so in the equation. So let's go up to our unknown, and then let's go ahead and hit alpha enter. Now notice that your response might have come out to be negative. That is because we need to treat your payment as being a cash flow out. So we're going to hit second DEL. That way we can insert this negative symbol and go ahead and hit enter. One more time to your unknown, hit alpha enter, and notice that it just swaps it to become positive. Now, please watch our lecture as to why we know that we have a future value with deposits versus withdrawals and so forth to kind of understand that material. All we're doing here is just understanding our. Now let's try again. Now this time, let's say we want to know our deposits, and this time we have your future value. So like example 3. It says find the periodic payments necessary to accumulate to $20,000 in a fund paying 6% per year with monthly payments for 5 years. So again, our unknown is now periodic payments. Now, everything stays the exact same except we're swapping our unknown. So let's go up to our top n, where we're doing the multiplication between, again, your m times your t. So again, this one shouldn't change at all, but if we wanted to, m times t. Your I here is really the interest rate, so your 6% per year. Again, this is as a percentage. Your PV, again, they don't state that we have anything in your account, so we can just say that this is 0. PMT we don't have, this is what we're interested in, so we can leave as is. FB, we do know we have $20,000 that we want to grow to, it'll be worth that much. And again, it's saying that we have 12 payments, so we can have your 12 down here. Let's go ahead and go back to our unknown. And again, if we want to avoid a negative response, let's go ahead and change your FV to show that it's that cash flow out. In which case, when we're ready, we can hit alpha enter. And you'll notice that we can have $286.66 for your deposits. So we'll be depositing about $290-ish in order to grow into $20,000, given that we have a 6% per year interest given monthly payments for 5 years. Now let's go ahead and try 2 more examples, this time with your present value. And again, we have 2 different equations depending on if we now have ending deposits or ending withdrawals or at the very beginning withdrawals. So one more time, all this does for us is that we are now swapping your unknown value. So if we're working with example 4, it says at the end of each month, you want to withdraw $50 from your account, earning 2% annual interest compounded monthly. You want the account to last for 5 years. What is your present value? And again, because we're talking about the end, we are going to be working with this one. Again, if we were working with the beginning, we just need to swap your payment. So we have 5 times 12. Again, it'll be 60. Your I, we said now, is back to 2%. Your PV, we don't know. That's what we're going to find. Your payment, we do know to be $50. And to avoid having that negative come up, we'll just hit -50. We don't know what we want to grow to. In other words, they don't tell us explicitly what your future value is. So that can remain as 0. We are making withdrawals every month or compounded monthly. So we are doing that for 12. And now let's go back to our unknown, your PV. Let's go ahead and hit alpha enter. So in your account, if we want to withdraw $50 each month with an annual interest rate of 2% over the next 5 years, we want to make sure that your present value is $282,852.62 to be in that account. And again, we can do it one more time with the reverse. If we are trying to look for your present or your payment and we have your present value, we'll do example 5 one more time. So this time we have 4 years times compounding quarterly under a 4% interest rate yearly. We have $100,000 in our bank account. We don't know your payment. We don't have anything that we're growing to, and we are under quarterly. So let's go ahead and discover your payment. So we should be paying into the account, we need to withdraw, figure out what we are withdrawing. So we can withdraw $6,794.46 into account that has $100,000, 4% annual interest rate over the next 4 years, compounded quarterly. And again, we want the account to zero out after the 4 years. Now, this is how we can get familiar with your app. So hopefully you found this informative.